Alright, since I'm not going to be here today, I wanted to leave a refresher for anybody that wasn't here on Wednesday on how to read each of these maps. And if you're not sure with the equatorial map, I'm going to run through that as well, showing you how to do the coordinates, the right ascendant, declination, and apparent magnitude. So I'm looking at one of these. These are the constellations that are on the polar map, the circular map, and we've already done in class the Big Dipper, Ursa Major, and I want to do an easy one to kind of show the idea of how to do this. So I'm going to go for Cepheus. That's the one we're going to do next, and you'll find that by spinning around the map looking for the boxes that have the names on them, and that'll tell you the general area to look at. And Cepheus is right around the 22-hour mark, and it is kind of what I like to think of as like a little house, a square with a pointy roof. So looking at the picture as a guide, I see that part of it goes from this A alpha to what looks like D delta. So that's kind of the bottom of the house. So looking at Cepheus, I find alpha, the little A, and then delta, the kind of fancy D shape. So that's going to be my first line. Then it says go from delta up to the little lowercase I, iota, which is there, and then go from that up to gamma, the little Y shape, which is over here. And it looks almost straight, but and then real sky it's bent. And then beta connects alpha to gamma, which is this beta here. So that is Cepheus, and I will show you how to go through and do the right ascension, declination, and magnitude. I'm just going to briefly talk about the magnitude because I don't want to keep switching back and forth between the constellation and the little key. Key is pretty easy to read. If it's a big dot with a circle, it's either 1 or 1.5. If it's a big dot with nothing in the middle, it's a 2 or a 2.5. If it's got a little triangle in the middle, it's a 3 or 3.5. If it's got crosshairs on it, it's either 4 or 4.5. And then you get to the small ones, 5 and 5.5. But I don't think any of ours are that small on the constellations. So you can do these in any particular order. I like starting with alpha whenever possible, just because that's the brightest star. So this is going to be Cepheus. And starting with alpha, fancy looking A. Its size looks to be about a 2.5. And then we have to find the right ascension, declination. Remember that right ascension is what you measure as you're going around. And declination tells you how polar or equatorial you are. So we'll do right ascension first. So using the strategy that I introduced yesterday, I'm going to draw a line connecting each of the stars to where it should be on the tick marks. So looking at XX1 or XXI, that's 21, 22, 23, and then 0 of course would be the reset, or 24 hours. So I'm just going to lay my ruler down at the point here. and then through the star. So at the very center of the map, through the star, and then I'm going to draw it out, and I'll label that alpha so I don't get confused with all my lines. Do it again from the center through beta. Do it again for delta from the very center. Oh, this one is beta. This one is going to be delta through iota, a little I, and then through gamma, the fancy looking Y. Like that. So I'm going to zoom in so you can actually see me counting through the right ascension and declination. So that's why I wanted to do all of the tracings out to the edge. So we talked in class about how each one of these tick marks is worth 5 minutes because 1 hour is divided up into 60 minutes. So looking at the right ascension, this is 21 hours and 5 minutes, 10 minutes, 15 minutes, and it looks like it's just past that. So it's going to be 21 hours and 16 minutes. For the declination, it's all about how close to the pole it is. So remember that the center is going to be 90. The next ring out is 80, and I'm just kind of writing on the map so we can see it for future reference. This is 70, this is 60, and then this outside line is 50. I guess I'm kind of writing over my tick marks, but I can still read them. So I've got 50, 60 degrees. This up here is 65, halfway between 60 and 70. And then I just kind of estimate 61, 62, 63, 64, 65 is up there. So maybe a little bit like that. So 1, 2, 3. It looks to be about 63 degrees. And everything on the circular map is going to be degrees north because it's the North Pole. Moving on to the next one, the beta. If I go out here, this is 5, 10, 15, 20, 25, not quite 30, so I'll call that 21 hours and 29 minutes. 21 hours 29 minutes. And this is for beta, and I didn't do the star. It's got a triangle in it, which makes it either a 3 or a 3.5. It's kind of big. I'm going to call that a 3. And then for the declination, it is almost right on the 70 line, but it's a little bit above, so I'm going to call that 71 degrees north. Moving over to kind of just working with the clock direction here with delta. So delta is our fancy looking D. It's got crosshairs on it, which makes it either a 4 or a 4.5. I'm going to call that a 4. As long as you're within the half, you're all right. And then right ascension, this is the hour 22. X is 10, I is 1. So that's 22 hours and 5, 10, 15, 20, 25, say call that 26 minutes, 22 hours. For its declination, remember that this is 50, this is 60, so we kind of estimate this is probably about 59, 58, and I'm thinking it's probably pretty close to 58. So, is that right? Yes. 58 degrees north. Moving around the circle to iota. So it is the fancy lowercase I. I kind of marked it up with pen. I think it's got a space inside. I think that's maybe a triangle. So I'm going to call that a 3. It's one of the downsides of drawing the lines out like this. Sometimes you obscure what symbol is supposed to be in the dot there. So it is also 22 hours, because theirs are 23 and it's not quite that. So it's 22 hours and 5, 10, 15, 20, 25, 30, 35, 40, 45, and it looks halfway in between. So call that 47 minutes. 22 hours, 47 minutes. And then declination, it is up above the 60 line. It's got a little tick mark here for 65. So this is about 56, 57, 58, 59. So I'll call that 65, 66. 66 degrees north. And the last one, kind of higher up in the sky, that is gamma. It's got a definite triangle in the middle of it, so that looks like about a 3.5 to me. For right ascension, we're looking where that line goes out here, so it's 23 hours and something. It's 23 hours, XXIII, and 5 minutes, 10, 15, 20, 25, 30, 35, not quite 40, so I'll call that 23 hours and 39 minutes. Declination, it's highest up in towards the pole. So if this is my 50 circle, 60, 70 here, and this is my 80 up there, that makes this 75, 76, 77, 78, 79. It's kind of close. I'll call it, let's say 75, 76, 77. 77 degrees north. And that's all of Cepheus's stars, just those 5. So hopefully you got that general idea about finding the right ascension by determining where it draws its line out to on the sort of clock face that we've got, and then the declination, which circular distance from the North Pole, 90, 80, 70, 60, 50. And I'll be making a separate video on how to read the equatorial map.